to Quantum Kinetics. I'm your host, the CEO, First Diffusion, and I'm here with
Jason MacCoy.
Jason, it's so good to have you on the show. What are we going to be talking about today?
We got a good one today. A lot of research done, a lot of explorations, a lot of phone calls at all times of day.
Well, what is it? What are the topics going to be?
Well, it's some very interesting stuff because we're going to talk about how some of the designs in nature, specifically in a sperm whale, relate to the radar technology that is also potentially part of the design of the pyramids.
That's a pretty big jump, Jason.
Yeah. I mean, it is an amazing thing to see how the two things in a very specific way do relate. As crazy as they seem.
Let's take the audience through it one by one. But before we do, Jason, we have a question from the audience.
Okay.
And the question is from Fester Rat Sub. He says, so how come the government or industry is not interested in funding you? How long would it take to commercialize your technology? You have a thought on that?
Well, I'll weigh in on this, and of course you have the final word on it, but I would imagine there's a couple different kinds of obstacles in the mix here. Like there's a lot of people that make a lot of money from existing industries, and that's part of any kind of innovation, right? Sure. You're trying to get market share, you're trying to get in, but there's also a tremendous need. There's so much waste that needs to be cleaned up. There's so much need for this technology that I don't know. It seems a bit 50-50 to me. And I mean that in a really good way. Like there's obstacles, but there's a tremendous demand for it. What do you think?
Well, from the experience that we've gone through for the last 7 years is that it's not an easy straight road. You think that you got a great idea and then you can just go to market and build it. But, like when we went over to the Department of Energy and showed them what we had, and I had a closed door meeting with one of the representatives, and she said, well, just send everything you got. I want to look at your stuff. And, there have been things that people say that they can do, and you're doing the things that we want to do. And so we send over the content thinking, oh my gosh, we're going to get some help. And then they go dark, and they got our information. And so at that point, I copyright protected that research that I gave to that individual. So again, truth is stranger than fiction. You think this would be okay, let's rock and roll. But apparently, like you said in the beginning, there are people with powerful interests that are already entrenched that, may not want this to come about or in their way, right?
And also, I got to imagine it's specific technology and a specific equipment. I said that to you probably in the early days. I'm like, why don't you just build one of these things and let it rip? You know what I mean?
Well, you need a client, right?
You need a client, and also there's as I've look around and see the technology, you've got real gear and there's real technology around here that's got to be expensive. So
it's taken a lot of money, it's taken a lot of time to do the patents. Everyone doesn't realize what it is to be an inventor anymore because there's not that many inventors out there,
right?
Just go to work, hit the nose of the grindstone, make that money, and blah, blah, blah. So,
yeah. And also, just to expand on that, you have to have a diverse set of interests and intellect to be able to learn different things about different things and then synthesize them together into an idea.
And that's what we're going to do today, talking about the sperm whale and its radar. Amazing. And it's sonar, basically. It's sonar, and sonar is basically just sound vibrations pinging.
Right.
And then radar is just electromagnetic photons that ping too.
Okay.
And so the sperm whale, did you know that the sperm whale has the largest brain in the entire animal kingdom, mammals?
I did not know that. I thought the elephant did or something
the sperm whale has the cake.
Huh.
It's the biggest one.
Wow.
And so the sperm whale, the reason we're going to be talking about the sperm whale is because what it does, Jason, when it tries to go and hunt for squid, is that it will actually dive down into the depths of the ocean where it's dark and there's no light. And so the question is, how do you see in the dark?
Well, I know that dolphins and orcas and belugas and all these other kind of whales.
Orcas, yeah, definitely.
Yeah, they send out a ping almost. Ping, or click, 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 click. Yeah, and then it bounces off something, and then they can almost see it, image.
A projection, right?
Yeah.
So what happens is they have, for the sperm whale, on the front of its nose, it takes a really tiny signal, and it has these lips that kind of move back and forth, kind of jitter, like that. And that vibration goes through the spermaceti, which is basically an oil in the brain. It's huge. And that sound wave hits the back of its skull, which is a deflector dish.
That's so cool.
Concave deflector
Parabolic dish.
Parabolic dish.
Yeah.
And then that sound wave that's got amplified in the spermaceti oil, which, by the way, we almost hunted them to extinction because of that spermaceti fluid, is an oil as a lubricant and a candle thing.
Yeah.
Because it has a lot of hydrogen in it. And so the sound hits the back of the skull, reverbs down towards this thing called the junk, which is basically these like layered fatty layers, which is controlled by a nose muscle that moves it like a lens back and forth. And so then it deflects out the sound wave that's amplified at a target.
Wow.
Or even at its family members it talks.
Right? Yeah, they have a very advanced language.
It's a dialect, actually. They actually have cultural dialects of different pods. So they're extremely mentally smart and communicative, and they use their clicks to hunt squid in the darkness of the ocean.
Wow, it's amazing. Now, you mentioned the design of this thing. So just, we talked about how does this design relate to the things we're going to be talking about next, right?
Yeah.
Sonar.
Yes.
Radar. Reflective dishes. Sort of like when you focusing the junk that focuses the sonic
beam.
energy.
It's a beam. Basically, it takes like a sound that goes in all direction, like an omnidirectional sound, and then it converts it into a direct beam. So it's right out in front of it. And wherever it turns its big head, it goes click, click, and it gets a picture of the ground and the ocean, but also it's hunting for things that are moving.
Right.
And so when it reflects back, how does it pick up the reflection, Jason?
Well, I'm glad you asked me that, because I was going to tell you about that. So there's a thing called Yagi antenna.
Yeah.
Yagi, maybe.
It is Yagi.
Like Mr. Miyagi, yeah. And it's got these, like, the whale's jaw has teeth on both sides of it that actually help it pick up the reflected sonar energy and give it a better resolution. Like if you were to design a Yagi antenna, it literally looks like the lower jaw of the whale.
It's crazy. Even it looks just like the orca whale, except it's a lot shorter.
By the way, real quick.
Oh yeah.
Cheers.
Cheers.
Shout out to
Mother Nature and all her secrets to nuclear fusion, because this is it.
That's where we're going with this, by the way.
And hold on to that radar antenna information, because that Yagi, the way that those teeth, they're actually rolled back. The teeth are not actually used for chomping the squid. All the teeth do is they just close up in on the mouth, because the top jaw does not have any teeth. It's just the bottom one, really.
Really? It's just like gums?
It's gums on the top. And so it just holds the... So what happens in my theory is that if you're a submarine going down into... And by the way, the sperm whale, it can go further down in the ocean than any of our naval submarines.
Wow.
Its technology is better than our best of the best subs.
That's so impressive, nature. Of course, nature does something awesome. But at that scale, that it really is, it's like a big machine. I mean, it's got a radar dish. It's got an antenna for picking up signals.
And the jaw goes right into its brain, basically. There's a little sac of fluid that the jaw connects to. And so as it's vibrating the jaw, it's picking up the signals of like the picture of the ground of the earth or the ocean floor or even the squid. And then it tells it to its brain what it looks like. And so what I think, it's like an F-16. A sperm whale's technology is just like an F-16 or an F-22. When you're flying an F-22 and you're like 30,000 feet above the earth and you're scanning with your radar on the front of your nose back and forth, it's called scanning. And you pick up a ping on the Doppler. You go, oh, there's a MiG out there. Yeah. And the reflection wave gets picked up by the radar on the front of your nose.
Well, there's two things that are interesting about that beam that it's sending out. Because as we watched a lot of videos for this particular episode, literally every day, about 3 times a day.
And we'll be putting them on this
videos, like shorts. I mean, everything all the time. And it's been interesting because, it starts off with like, check out this video. But then we're like, but what about this and what about that? And 4 or 5 videos deep on a particular topic,
It's a black hole well.
it really does pull you in. But so the beam that it projects in some of the videos, in one case, they said a lot of people think that what it does is it blasts the squid with like a powerful thing, like punching it hard.
Well, from what I remember is it's getting closer to the bottom. It goes click, 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 click. So it's getting a higher resolution. It's getting closer.
Right.
And then I'm sure that when it sees something move, because when you get hit by that click, that's 230 decibels.
How loud is that?
That's
is that a train going by or
no?
What?
That's like an F-15 at full afterburner.
Like flying by?
Yeah, full afterburner.
Buzzing the station or whatever?
Just like
the
Maverick.
Tower?
Yeah, just like Maverick.
Wow.
Can you imagine like that? And there are some scuba divers that have divers that go next to the sperm whale when they're checking them out at the surface. One guy, what did he put his hand up against it?
Yep.
What happened?
His hand was numb for like 4 hours.
Jeez.
By the way, there's another kind of interesting detail about that. They said when they go and dive with the whales, they can't wear scuba gear.
Right.
They have to
be flesh, no scuba gear.
Right.
No
like
nothing.
I imagine a snorkel and that's it. And you're just, because the whales, in another one of them, the guy said when the whale kind of
at you,
looked at him and was scanning him.
How scary, dude.
His body, he could feel his body heating up.
It's like, in an aircraft, like an F-16 or an F-22, when you're on the deck and you're like landed with the landing gear, your radar is automatically turned off. You know why? The landing gear has a pressure sensor that says, oh, the gears are being pressed down and it's on the tarmac. So that then the radar is turned off. But if the radar ever gets turned on while you're on the ground and someone walks past it, they can get hurt.
Wow.
Like real bad.
Because of the energy of the radar?
Yeah, it's so strong.
Well, maybe that's what the whale can do both. We took a little deep dive, no pun intended on that one, about what the squids would do, right? I mean, this gets into the woods a little bit, but
if you're hunting, you want to suppress your prey and get them stunned.
Right. But the squids are squishy, rubbery.
Silicon.
They're almost built to be defensive against it. And the whale's it's like an arms race against super radar and super tracking versus like super agility and rubber body.
Yeah, it's basically almost transparent. Like the sound waves kind of go through the squid, but not all of it, because if all the waves, the sonar waves went through the squid completely, you wouldn't be able to see it on the sonar. So some of the waves bounce off of the squid. We know that because they can track it. And if you were, the mouth being the antenna that's receiving all the signals, and if my brain is pumping signals out to get a resolution. Wouldn't you just bring your antenna right up to the prey? Like the closer you get, you just put your antenna right up to it and grab it.
Right.
It's locked on. And then you go, okay, I got it. And I'm going to go up to the surface. Right.
And maybe it stuns it too. And maybe, it's a combination of it. They said in one of the things that when it gets it in its mouth, it's got these giant big body and big lungs and it sucks it in.
Right. It grabs it, it holds it, and then it basically pulls it to the back of its throat and then just starts sucking on it.
Yeah.
And so then it basically suctions part of it into the belly. And it's like, dude, that's got to be a terrible, awful death.
That's a tough day for a squid. And there's a lot of them. When they open the body of the sperm whale, they can see what it's been eating, and it's all these giant squid.
I think they take a dive every, couple hours, don't they?
It's pretty.
It's like 9 times a day or something like that. It's pretty regular.
And they sleep up and down. Did you see that? I have a theory about that.
I want to hear your theory because you haven't told me yet.
Well, it would make sense that if you're if you're this way sideways, you might drift around and get I don't think it would be you're not plumb, but this is plumb. And so you kind of just stay in a spot.
That's a great transition to Benjamin Franklin going vertical with the kite.
Benjamin Franklin did do some experiments with the kite.
So now that we've discussed the sperm whale and we kind of have an understanding of this thing is basically a radar dish tracking high technology hunting machine.
Yeah.
How can this radar technology where you're emitting radiation out, even a sound wave, receiving information back to make a decision to go attack something or do something? How does that relate to the pyramids? And what do we know What was the most recent thing that gave us kind of a tip off to what this is going on?
Okay, but before we get into the pyramids,
We got to talk about Ben.
we got to. I was going to bring in a $100 bill. Fortunately, I only have Jacksons, which are 20s. But Benjamin Franklin, as a lot of people know, did this experiment because at that time, you can fill in on that one, but everybody was crazy about electricity. It was like all the rage, and people were experimenting with it, exploring what it can do. And Benjamin Franklin did a test where during a storm, he flew up a kite. The kite had a hemp string. And they were saying that if it was wet, that would make it conduct electricity.
Yes.
And then there was a key on the bottom of the kite string.
Yeah.
And then he could feel during an electric storm if it gave, if it sparked a little spark. Help me out with that. What happens after that?
Yeah. So if you have a kite that's high up in the air, now here's the thing that people probably don't understand or know, but every single meter, which is 3.2 something feet, every meter you go up from the ground, you go 100 volts potential high. So if you're higher, so if you're like at, how many meters? You're at 10 meters. You're at like 10,000. You're at 1,000 volts. You're at 1,000 volts potential. And the pyramid, interestingly enough, is about 450 to 480 feet tall. That's like 14,580 something volts.
Okay.
From the ground. And that's just steady voltage.
So
no pumping,
the
just
higher
there.
You go up into the atmosphere. Now, we were talking about this the other night about that video.
Yeah.
And I like because you had a lot to say about that one. You're like, that ain't how it really works, right?
I did have a lot to say about that.
Okay, so let's go through that just to kind of help everybody understand this. You got to keep an eye on the other thing.
The charge potential, right? Like the charge potential from the ground to the clouds, right?
Right.
So we all know that the Earth has a lot of electrons because it's ground. That they call it ground for a reason. That's where all the electrons are. Yeah. But the sky has a depleted amount of electrons compared to how much the electrons are on the ground.
Okay, so hold up. We got a bunch of little minuses on the ground.
Bingo.
And a bunch of pluses in the clouds.
Bingo.
And those guys want to equalize, right?
Bingo. A capacitor.
Okay.
It's like a capacitor. It's like two plates. It's like this plate has a whole lot of electrons, and this plate dielectric has very little. And so there's a pulling. Like this wants to be pulled this way, and this wants to be pulled that way. Like it's a charge. And that's what keeps the atmosphere around the planet is this charge potential.
Cool.
And so there's a magnetic field that's involved with that from the core of the Earth, and then there's electrostatic, which is called mass to charge ratios, blah, blah, blah. But the most important thing to know about the kite is that there's negative charge on the ground, and the storm is causing a huge amount of like charge differential.
Okay.
And so when he's got the metal key and he's touching it like this, he's getting sparked because his body's equalizing to the positive part.
That seems kind of dangerous.
Dude, if he got struck by lightning, he'd be dead.
It would just, because he's kind of creating that conduit.
Yeah, because his foot's on the ground. Because then it just, electrons like to find the path of least resistance. They just go right on through you.
Okay. Yeah.
Or metal. Really, really, really well. And matter of fact, gold and silver have the best conductivity. Better than copper even. Right?
Right, yeah.
So it's like maybe these materials have something to do with the pyramids.
Maybe, absolutely.
Which we'll kind of get to that.
Absolutely. That's good to mention that, because kind of where we're going with this, is this premise about the pyramids and including the technology from the sperm whale in regards to like radio technology, emitting a vibration, receiving a vibration. Okay, so if the viewers are wondering why are we talking about sperm whales? There's this.
Here it comes.
Yeah, we're going somewhere with this, which is the sperm whale can emit high frequency or vibrations of all kinds. It can focus them.
Yep, sound waves.
It can speed them up or slow them down depending on what it needs.
Focusing with the junk.
Right. It can turn it into language, which is a whole nother thing.
Which is a beat.
Yeah. And Benjamin Franklin, regarding the electrical differential.
Yep.
These all have to do with the pyramids.
Absolutely. So here's the thing. In order to make electricity flow, you have to have a voltage gradient. You can't make 0 volts electrons move. You have to have 1 volt, half a volt, 10,000 volts, a million volts, and then the electron will try to flow. But there's one thing before we even get into the pyramids, there's something that every one of you have to understand, is that this is a new discovery, that the electrons that flow from the ground up to the clouds, that's the lightning strike that you see and you hear. That big flash and there's a big bang. That's electrons flowing and being released from the earth
Up. Okay.
But with recent technology and cameras, we have seen that there's this thing called a step leader that comes out of the clouds first. And it looks like these organic vein artery type things that shoot down in pairs of 3s and Fibonacci spiral stuff, right? And it's looking for the ground. But this happens in fractions of a second. You could never even see it with the naked eye.
Is it like a pathfinder? Is that kind of what it's doing? Like it's like sampling all these little cracks and crannies to get to the, yeah?
It's thinking. I think it's very much like what the brain's doing with the sperm whales. It's sending out pulses to try to figure out what's going on out here and try to find the squid. And then it rebounds back and says, oh, that's the path. Keep going that path, get closer and closer.
Huh.
And I think that these step leaders have some type of intelligence for energy harvesting. It's very important, but the step leaders that the pyramids, this is what it's all about. You don't want a beam of electrons discharge. Show it. So this is a 3D model of the pyramids with the new discovered structure underneath it, and this is to scale. And you can see that those long channels, that is 2 kilometers deep into the earth. So the pyramids sit on a plane that's perfectly flat almost, and these tunnels, these tubes, we call them resonant chambers, like a Helmholtz resonator. We can talk more about that, but here's a demo of what those tubes would look like. And this is just a hollow tube, a stainless steel with a coil wrapped around it. Now, if I put my hand on the bottom and I blow over the top, you can get a whistle sound, right? Huh. So there's a Helmholtz resonator inside of here that's compression and making some type of motion right here.
Wait a minute, let me do it with the beer thing.
Right, and yours is more drink, right? And mine's less drink. Now listen, the pitch will be higher. You see?
Oh yeah, wait.
So the longer the shaft is, right? The longer this shaft is, the lower the resonant frequency is going to be for this. And if this is 2 kilometers.
How long is that? How long is how big is it?
It's more than a mile.
Like a mile and a quarter, right?
It's pretty far. Yeah, it's pretty
That's
far.
Huge.
And so these chambers on the bottom, they're 80, what are they? 80 meters in diameter. They're huge. Each one. It's almost it's a football field basically on the bottom there.
Whoa.
2 of them, right? And so a Helmholtz resonator is something that has a neck. We talked about this on one of the episodes too, but it has a neck, which is this. And then it has a resonator on the bottom that determines the frequency. And then it vibrates the top of the pyramids, the plane. So that is our premise, that basically it's a resonant Helmholtz resonator, but it also could be a choke coil.
Okay, what is that?
So a choke coil is something that they use in radar technology to smooth out signals to the radar dish. It's something that it's like a low pass, high pass. So it's like a waveguide. It lets certain frequencies through, but then excludes other frequencies. So with this one being as long as it is, would only accept long frequencies into the resonance.
Low, long,
maybe Schumann resonance level.
7.83, huh?
Maybe. It makes sense.
So, okay, let's just take a step back here real quick and tie some of this together if we can here. So it's possible that the bottom structure of the pyramids, that these are Helmholtz resonators.
Yep.
And these could be choke coils.
Mm-hmm.
And it could be absorbing the energy from the resonance from the earth.
Which is the core. That's always churning.
And always going
boom, 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 boom. It's like a heartbeat. Boom, boom. Every planet has a heartbeat, actually. You know that?
Huh.
Even the moons have a little bit of a heartbeat. Boom,
Actually,
boom,
no, I didn't know that,
boom.
actually.
Yeah, they do.
Huh.
One of the moons is spewing out like a lot of volcanic activity, and it's from the churning inside the core of
Is
the
that
moon.
Europa?
It's one of, yeah, I think it is. You got your astronomy.
Every once in a while, that's the ice thing, right? And then
Yep.
like it cracks open all the time.
That's right.
There might be giant sea monsters down there.
And so these phenomenons for radar technology that we use in like military and we use for, even our cell phones as Wi-Fi, which is, 4 gigs or 5G or whatever like that. We use the same philosophies and the same principles to make signals go somewhere. And so in terms of the pyramids, if this is true, if we have the churning heartbeat of the earth going 1, 2, 3, and that's free energy, by the way. It's a small signal. Vroom, vroom, vroom. I would need some type of tuning device that would be tuned to that little input signal, right? So that can amplify it, just like the sperm whale, right?
To receive it, right?
Yeah, to receive it and then amplify it.
That's so cool.
And so in terms of radar technology and also the quantum kinetic well technology, you do have to have a pulsing on the bottom. You have to have the choke coils on the second, and then you have to have a capacitor that's linked to something. And here's the thing. What is the pyramids made of?
Limestone, right?
Yeah. What is limestone?
I thought
What's
it
so
was
cool
like,
about it?
well, calcium, but from like seashells or like broken up seashells.
Mm-hmm.
And I don't know, it's a capacitor.
It
of some
has
kind?
aluminum, and it has little shards of aluminum, calcium,
Oh wow.
potassium. It has all this weird. It's a hybrid material. And the cool thing about the limestone, it's actually new discovered that it could be a supercapacitor with a 99% efficiency charging potential.
99.
99% efficiency.
Wow.
So here's the thing. How many stacked blocks of limestone are there in the pyramid going 450 feet tall?
A bunch.
There's like 200 layers.
And each one of those layers. Now, what's the deal with layers? It's like a Seinfeld thing. What's the deal with layers in pyramids? What is the deal with layers in pyramids?
Well, there's this thing, Jason, called a 3-dimensional integrated metal oxide transistor. Sorry, that was a mouthful. But what it is a stack of like transistor, anode, cathode, gate, transistor, anode, cathode, gate, transistor, anode, cathode, gate. And what that does is it creates a charge pocket. A really interesting charge pocket.
Now, you would say, when you say charge, there's one sort of ingredient I feel like we kind of may have left out here.
Mm-hmm.
Piezoelectric. You take all that vibration, or you have all that energy, and what is the piezoelectric dynamic of this?
Well, piezoelectric dynamic essentially is you take a voltage, like a positive and negative, and you hook it to a piezoelectric wafer, which is really thin, and you turn up the voltage, it'll start singing. The lattice structure will start flexing and moving, and then the electrons flow back and forth, and it makes it start singing.
So we put electricity into it, and it vibrates?
It vibrates, but it's at the atomic level. It's not like an actual like lever where it'd be like, I'm moving the lever this way, I'm moving the lever this way. What it is like a longitudinal fluxing of the lattice structure of the actual material, which would be a longevity, a long duration of usage.
It's like a perfect design. When we talked about this in the research of this, it's a perfect design where there's really no moving parts, and anything that is moving is at an atomic level, right?
Absolutely. You have the electrons potentially flowing in the coil, causing a magnetic field to grow and then contract, and then it's pumping voltage up into the plateau, which then is charging the piezoelectrics at the right frequency. And here's another crazy thing, Jason. If I have a piezoelectric dish like this, and it's this thin, the resonant frequency of this is like a really high frequency.
Okay.
If I put another wafer on top of it like this, now it's doubled down. It's lower frequency. Okay, now if I put another one on, it's a lower frequency. If I put another one on, it's even lower frequency. I put another one on, it's even lower frequency. Now what happens is, I think the pyramids, the height and everything is linked to the choke coil. to resonate the capacitance and the inductance together to create a pump, a Helmholtz pump.
From the vibrations of the earth
Yeah.
into the piezoelectric crystals,
Yep.
into the layers of limestone, higher and higher.
And so now, instead of your charge being ground state here to the top at like 4,000 or 14,000 volts, as this thing is pumping, this thing is now charging to like million volts potentially.
And it's in the air, just like the Benjamin Franklin experiment, like flying a kite up there. Now you're at the top of the pyramid. Now, there was some interesting things about the capstone of the pyramid. Some people think it was made out of these exotic metals. Well, how could that relate to the design?
So there is a Ben stone that was found, and it's like this basalt black triangle thing, and it has like these really cool engravings in it, and we'll show it in B-roll here.
Yeah.
But that was not even from the Giza Plateau pyramids. It's from another pyramid that was farther away. And so nobody knows where the capstones are for the Giza Plateau pyramids. Nobody knows where they are. But what's interesting about them is there was definitely something sitting on top, because they're all flat on top, right? There used to be something there. And I think, and this is just a theory, and because the ancients would call the Ben stone the stone from the heavens. That was the theory, is that the Ben stone was basically, if it was a star stone, fell from the sky. It was a star that fell to the sky, fell down.
So maybe like an asteroid or something, or?
Well, I think that stars are actually made, and all planetary cores are made of something that looks like this. A black magnetic rock.
What is it? Magnetite?
This is magnetite, yeah. And this is what we make in our reactors with a quantum kinetic fuser and the arc reactor technology with water. We make this material all day long. And the longer you leave it on, the more it makes of this.
So when you say it makes it, what you're talking about is it transmutates water into a mineral.
A magnetic rock that has a very special shape.
And that's called transmutation, right?
Bingo.
And okay, so let's just go off the rails here a little bit. Why would it make that shape? What is this, an octahedron?
I think so, yeah.
The 8-sided dice for all you role-playing game cats out there. Oh, yeah. Oops.
Oh, you just grab it. It's all good.
This thing seems tough. It seems...
Well, it is very tough. It's got a tough hardness to it. And you can electroplate that too if you put a conductive material, because that's actually technically a semiconductor. It can conduct, and it will conduct at certain situations.
So has this been manufactured, or is this naturally?
That's how they come naturally.
Because of the crystal structure? Wow.
Because the atomic lattice structure of a magnetite is Fe3O4. And then when you put the atomic structures together in that way, they make a diamond. It's just what nature does.
Fe3O4. That would be iron and oxygen?
And actually, you can make it with carbon too. There could be a hybrid material.
This is just a total lay chemistry question, but isn't iron and oxygen like oxidized? Isn't that what rust is? Or is that special? That's not rust. That's something other than that? It's crystallized differently, or what?
Well, there you can get hematite, you can get magnetite, you can get thermite, you can get different types of oxide iron
from that.
But when you put water through a gravitational well, you get these hydride magnetite crystals.
And that's one of the things that comes up when people ask you, like, what does it do? How does it do it? You're saying, and the tests prove that you can put pure water into the reactor, and somehow it's making other things. Yes. And the only way it could be doing that is transmutation, right?
You want to know something crazy too, Jason? The limestone blocks of the pyramid, they think it comes from a place several miles away. But I have a theory that if you're able to do gravity synthetic transmutation, you could just use the Nile River and transmutate the water into a limestone. And actually the sediment from the water of the river lines up really well with the limestone blocks too. Using transmutation. I've actually taken like just tap water or river water and put all the sediment through electron microscope and looked at the differences between the Giza pyramids and ours, and it's very similar, within an 80% factor. It's very similar.
Wow. So if you had that water, you might see exactly like what they've got there. Huh?
Why would I, if I was an advanced civilization that could burrow an 80, kilometer tube down, 2 kilometers down into the earth,
A mile and a
a
quarter.
mile and a quarter. Come on, dude. And then I could stack these, limestone supercapacitor material perfectly.
Yeah.
You don't think I had nuclear fusion figured out? Come on, man.
It's really, I mean, the more that we research the design of the pyramid, and I think that's kind of the premise of all of this, is from the sperm whale to the work that Benjamin Franklin did to the pyramids, that if you take all the materials and if you take the system and these pieces that you can see with physical functionality, like the Helmholtz resonator, the choke coil here,
coils,
the capacitive capability of the limestone, and the capstone at the top,
as a superconductor, basically.
Which in some cases they thought was electrum, which is gold and silver alloy.
Well, why do they use electrum? What is so special about electrum? What is electrum?
Well, it's a gold and silver alloy, a mix of gold and silver,
schmelted together,
right?
Whatever.
Yeah,
schmelted.
I guess once you're an alloy.
Yeah, you just melt it.
You're melted together.
Yeah.
Metallurgists weigh in on that one, but
so it's silver and gold.
Silver and gold. Well, gold is super resistant of like corrosion.
Yeah, it doesn't get corroded at all.
And both gold and silver are super conductive of electricity.
They're very conductive.
And in fact, silver, interesting fact, is a little bit more conductive than gold, right?
Which is crazy.
Yeah.
That's crazy.
So you have all of this energy getting pumped into this pyramid.
Charging it up, baby.
All the time. And then all of that energy, some people, okay, now we talked about this too. Some people have mentioned theories about the chemical processing capabilities of the pyramid and some of these other alternative uses. But what we're talking about is you have the Helmholtz resonators and the choke coils are pumping all of this energy upward into the capacitors. You have a gold and silver tip thing at the top.
Don't forget it. It's a piezoelectric capacitor that's charging and moving. It's pumping too.
Wow.
It's pumping up the charge to the tip through the capacitor. So the pyramid stays capacitant. It stays voltage charged. And so something at the top is just basically flowing electricity down through the charges.
Wow.
Yeah.
So this is the part that is kind of interesting. It's both pumping energy up, but because like the kite experiment, what's up with that? Like it's also into the atmosphere, right?
It's pulling down too. Now here's the thing with the quantum kinetic well technology is if you create a very special situation in electronics configuration, you could in theory with the quantum kinetic arc reactor, you could in theory make the well in a special circuit configuration. If you meet those criteria right, it will automatically make a well down. Now, I'm going to tell you a secret, Jason.
All right.
That if you meet the criteria for the quantum kinetic well, you don't even have to have voltage put to the reactor and it will start doing quantum tunneling.
Just on its own?
Just at 0 volts, as long as it's in the configuration for the quantum kinetic well, it will start trying to do a well.
Okay, but hold up.
Without even having any voltage.
Hold up.
Which is crazy.
The hot fusion industry.
Oh. Okay.
Those guys been pumping money.
Billions, bro. Maybe even trillions over the last 100 years, 80 years.
Energy. Lots of energy. You have to, firing that thing up is like to try to get over unity, which means more energy out than you're putting in. They're they have to power these things with almost like the kind of energy that you would go for a data center, right? I mean, that thing has to have a lot of muscle to magnetically confine plasma, right? So a lot of energy, a lot of money, a lot of moving parts.
And it doesn't work yet.
Will it ever work?
No.
Okay, now this is good stuff. Okay,
it's never going to work.
Okay, well, right,
because
hold
it's
up.
not the pyramid. It's not the quantum well, man.
But can't you throw a bunch of money at it and a bunch of energy at it and muscle it over, push it over, kind of tell the natural process, with enough muscle, it's going to work? Or is it just, are we running up against like a limit of the physics?
Well, I mean, like the best analogy I can give you, Jason, is like if you go on a date with a girl and you say, hey, and you're really aggressive and you're really mean to her and you're like, hey, this is what I want. I'm going to take it from you. I don't think you're going to get a good mutual respect there, right? You're not going to get a mutual understanding. This is a give and take, right? Like Mother Nature says, I can give you everything you need, but I also need you to understand that I don't want to be used as a utility. Like I want you to understand that this is a symbiotic relationship. I don't want you to be using, fast neutron radiation. I want you to be using cold or thermal neutron radiation because my biology, my creational forces, the energy of the earth and this harmonic oscillating. Did you know that there's 3 harmonic oscillated resonant frequencies of earth?
No.
There's 3.
I thought it was just the Schumann resonance was the only one.
That's the fundamental.
Okay.
There's actually 2 others, and there's 7.8, and then I think it's a 10 point something or 12, 14 point something, and then 20. I have to look up my notes, but I know there's 3 of them, and it's very interesting that like it has to do with the oscillations of like the like music, like a chord, like dun 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 dun. So what? This to me sounds like a transformer. From my understanding of nuclear fusion and working with transformers for almost 10 years, is that every single transformer I have ever wrapped or made or tested with an oscilloscope and a pulse signal generator, every single transformer always has 3 resonant frequencies.
Really?
Always has 3, and that's pretty much it.
Huh.
So I think the Earth is its own transformer with its own 3 fundamentals.
And this is just built into the mass of it. This is just built into the volume of it. This is just
gravity.
Gravity.
It's built into the gravity of the dynamic system electronics.
Huh.
Because the Earth is actually designed like a quantum kinetic well.
Really?
It is very similar to the pyramids. And think about this. If you take a technology like a little tiny amplifier and then you put another amplifier next to it and then another amplifier next to it and then another amplifier, and you like the Simpsons, when Bart had their, what's the guy's name? Simpson? What's the main character? Homer. He has the little microphone and he's talking in the microphone. And he's got like 16 microphones out the window and he's trying to make a huge sound. That's what gravity is. It's basically it's an amplified signal on top of another amplified signal, and it just keeps going. And so if you take the Earth signal and then you put this that's tuned to it there,
you're going to get
signals.
You're harnessing the Earth's energy and you're making energy. Now, this also brings up
pulling it in.
You're pulling it in.
And this is where it gets interesting.
Okay. Now we got to take a second and talk about Nikola Tesla.
Mr. Radio.
Mr. Wardenclyffe Tower.
Oh, snap.
By the way, Wardenclyffe Tower, how come nobody's rebuilding that? That stuns me. Why? If we saw the greatest inventor in our modern history create something that he thought was one of the most exceptional possible things to build, okay, it got torn down during a certain time. It got destroyed.
1903 or something like that.
Yeah. I mean, but like we could, it speaks to the possibility of this configuration, like is part of the pyramids that could be generating power, making power.
Well, what did J.P. Morgan say? If it doesn't have a meter on it, I don't want it. Well, the pyramids, I don't think has a meter. I mean, if I was an ancient civilization that could do something this amazing, I don't think I would need a meter, right? I mean, if you think about this design, if this is really what it's doing, if there's something else that I want to talk about, which is the very top of the capstone, right? So we have this transformer that's beating in synchronization with the heartbeat of the Earth. A small little signal gets amplified up this thing, and it's pinging back and forth. And then this is charging. And then there's this conductor right on the top. Anything that is conductive, if I take this, and then going back to the Wardenclyffe Tower, if I take this, which is an inductor, and I connect it like this, and I pulse this, This is going to emit electromagnetic radiation like an antenna all day long.
That's the sperm whale technology.
Bingo.
Kind of stuff, right? Yeah.
That's it right there.
Cool.
Okay. Now here's the thing. Different shapes of antennas will do different things. You can have a monopole. You can have a dipole. This would be like a dipole where there's two signals going out. You can have one where it's uniform. What if the capstone that is gold and silver, super duper resistant to the atmosphere, corrosion, and it's super conductive, but it's being pulsed and emitting radiation out into the air? There is a really cool phenomenon that most people don't know about in radar technology. You want to know what it's called?
Sure.
It's called skywave.
Skywave.
Do you know what that does?
No.
Okay. Skywave is this phenomenon that if you have a radiation pulse going up into the sky, it will bounce off of, if it's the right frequency, it will bounce off the ionosphere and then come back down to the Earth.
Right. That's what that, the up and now, is that how that's how radio works, right? I thought like when you have a tower or whatever, it hits the ionosphere, bounces back down into your phone or your whatever and radio.
Only on a certain specific frequency band.
Okay.
From like 7 or 3 megahertz up to like, I think it's 30 megahertz. It's a pretty small band. I think it's called the K band, maybe. But it's really high frequency. And so if that frequency, if it's a longer frequency, it'll just go right out into space. If it's a smaller frequency, it won't do anything.
It bounces off that layer.
It has to be at a very specific frequency, and then it will bounce down.
Is that a, what is that, waveguide?
Basically, the atmosphere becomes a waveguide.
Wow. Okay.
Yes. Only for specific frequencies, though.
Well, the whole pyramids appears like if that whole thing is tuned properly, you could get the specific frequency for.
Now check this out. Just like the sperm whale locks onto a target with its clicks, click, 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 and it gets more intense as they get closer to the target. The pyramids do the same thing, and I'll tell you why. Because the pyramid capstone has 4 sides that are flat and they're bigger. The empty space that's sitting on top of the pyramids right now is about 33 feet by 33 feet.
Oh,
the
really?
base part.
Huh.
Did you know that 33 feet, in terms of that was an antenna, that would be the skywave frequency?
No.
Yes. In the megahertz.
By the way, there's a lot of number stuff with the number 33. That's for another thing. But, yeah.
So in my theory is that what happens is that pyramid is charging up from the core of the Earth. It's charging up the capacitor, and this thing is beaming out at a 60 degree, because this magnetite stuff is 60 degree angle, and the pyramid's at a 51 degree angle. So that actually causes it to want to sweep down even harder. And so the top tip of this thing is emitting outward at a 60 degree angle, the megahertz, and it's skywaving back down 100 feet to 300 feet to a mile to 100 miles out. And it's a gradient charge.
And is that getting received by those obelisks?
Yes, the obelisks that are all around the pyramid, and they have the pointy tops too. That skywave gets pulled back down into it, and then channels, which are conductive pathways on the ground too, they found.
Okay, so let me ask you something, because as I told you, one of my first video game that I worked on was all about ancient civilizations, and the premise was that they had these crystals that blew up. The alien crystals blew up and they landed in different parts of the world, and they used the crystals to basically like harness energy and project energy.
Not now.
Sorry about that.
That's okay.
I don't have my glasses on, by the way. If you see me squinting, I do that when I don't. But the idea was that the energy could be like projected around it and then picked up by these.
That's what
obelisks.
This is doing for sure. This is definitely what it's doing.
This is the projecting part, but then the other things are receiving it.
Yes. Yeah. So what it does is, with the capstone being a conductive material that is basic, and by the way, magnetite can get really hot and be stable. Actually, once the conduct,
hot?
it can get warm and it will conduct more. So as
really?
the ions are coming down, and here's the thing, there's another thing too. The edges of the crystal on the sides here, those are emitting the megahertz regions out at 60 degrees, but the very the very top is pointed, and that point has another radiation vector or radiation signature. It's in the gigahertz. So the very very top is flat, and it's a very small. It's like it's basically like a couple centimeters or something. And the radiation that comes off the top is 2.45 to zero point 0.9 gigahertz, which is the resonant frequency of nitrogen. Guess how much nitrogen is in the atmosphere, Jason?
Like the ratio or whatever?
Yeah. Nitrogen
70,
is like
maybe?
78% concentration in our atmosphere.
So what we breathe, most of it's nitrogen?
Yes.
Huh.
So this thing is sitting at the top of the pyramid, emitting a microwave straight up into the air, which is ionizing at resonance the nitrogen, and that causes electrons to flow down.
Whoa.
It's called a plasma channel.
Wow.
Yeah, and so you have a microwave beam going straight up, which is causing electrons to fall down because it's the P2 shell, which are the easiest to pull down. And then as those electrons flow across the sides of the wall, it actually starts emitting out radiation because of the pumping up too, and it'll emit out the sky wave energy, which then charges all the obelisk in the area, and it charges all the lines in the ground, and so then everyone's got power.
That's awesome.
No moving parts, completely resonant with the atmosphere, the Earth's crust, and the Earth's magma.
Wow. Okay, so let's do it. Let me see. This is a good spot to do a summary of all these premises, because I'm sure at the beginning of the show, people are like, how does a sperm whale have anything to do with the pyramid? Ironically, one's underground, one's above ground, one's an animal, the other one's a giant structure. But the premise of this is that if you look at the system of the pyramids and the materials and the configuration and the physics of what happens when you put this with this with this, you get the possibility of a super efficient and super optimized energy generator. Is that that's the main idea, right?
It's Mother Nature's way. I mean, if you look at it, it's using the radar dish technology of a small signal in, amplifying it, reflecting it, and then aiming it to do something you need it to do in nature.
Wow.
It's the pyramids. It's like if you were an ancient civilization that had all this great knowledge and you wanted to flex the greatest car or the greatest power generator, you'd be like, bro, no moving parts.
Yeah.
It can run for 100,000 years without stopping. And I can vector it, which we didn't even talk about how to vector the power.
What does that mean, vector? Like you can
turn it on full blast or turn it way low.
So if you only like, maybe like in the beginning of or at the end of harvest season, you have a lot of work to do. You're going to do stuff with this power. You need power, but other times you don't. And so you can turn it up and down. I mean, yeah. Wow.
You can vector the power, and maybe we'll talk about that later, but maybe we won't. But there is a way to control the intensity of the quantum well technology down over the pyramids. Wasn't it someone said something about 51 degrees being the primary flow angle of some type of high pressure to low pressure system? Did someone say that? I feel like I watched a podcast where someone said the angle of the pyramids is just so that it makes the perfect flow rate.
Yes, and it makes cumulus clouds, like lightning clouds, going up that angle. But there's so many things with geometry and how that stuff interacts and interfaces that I could be part of it too. I mean, there could be other parts of it. By the way, we should say there's parts of the pyramid that they still speculate have other chambers in them. There's aspects of the pyramids that you keep saying, you said this a time or two in our discussions, like, well, we could know if we actually could go down in that. Wouldn't that be a crazy trip?
I don't think the government would let you touch anything.
Could you imagine rappelling down those cylinders like a mile down? And how loud would that be? Loud in there? I mean, if you got all the way down to the Helmholtz resonator, is it like bzzz, super loud?
Probably feel static in there, like you know how you go onto like a mountain range or a canyon range, and sometimes there's a charge there as the wind's coming up.
Yeah.
I wonder if you'd feel a charge in there.
Well, Well, let's book a trip. Let's go.
Well, let's let things simmer down politically out there in the world. It's a little crazy.
Maybe. All right. Well, we'll book our exploratory trip to Egypt and another time. But wow, that's really interesting. I mean, all of that. Okay, then let's take a moment and just say to the people that are watching this, and they're like, you guys are kind of injecting it with meaning. You're injecting it. This whole thing is just a big
thought experiment.
Well, no, like what are they? Where they bury guys?
Oh, a tomb chamber.
A tomb chamber. Yeah,
it's definitely not, because here's the thing: like, it just can't be.
Why would you put all that extra energy, all those tubes down there that also happen to be a Helmholtz resonator?
It is fair to say, Jason, that the Egyptians did not build the pyramids; they inherited the pyramids. And it's very, very possible that the pyramids are well over 85,000 years old. And I'll tell you why. Because the constellation of Orion's belt, if you go back 85,000 years to 100,000 years, the stars actually move. They actually shift over time, right? And you can tell that which direction they're going if you just watch them in current day. But if you take the clock back 100,000 years, that is when the pyramids of Giza line up perfectly with the Sagittarius belt, the Orion's belt.
And is that called, what is that called? Persistence or precession?
Precession. Because everything's rotating around everything else.
Right. That we're in a particular zodiac sign during a certain, like 26,000 years, I think it is, or something like that. And then the earth shifts to face another one. So you're saying that if you were to sort of go back in time, it would be pointing and related to that constellation. Is that? And
exactly where the stars would be aligned at that time in time, going back in time. Now, here's another thing that just blows my mind, bro.
What's it?
This is another reason why the Egyptians, there's no way it could have been the Egyptians, because the site of the pyramids, the latitude of the Great Pyramids is 29.9792458 north.
That sounds familiar.
That is exactly the speed of light in meters per second.
Wow.
299,792,458. It's exactly the same. So if you were an alien species that flew into this dimension with all these criteria of like the speed of light, permittivity, and capacitance, and there's a whole new dimension, I would flex like that too. I know this dimension like the back of my hand. All right, I'm going to the next one.
And you're building it into the structure itself and as part of its design. And and who do you think might be building that stuff?
Well, I don't know. It's okay. Don't worry about it. Don't worry about it. It's okay. So the premise that the Egyptians made the pyramids is totally whack. I mean, seriously, I'm sorry, academics, but it's whack. Just like nuclear fusion. You got to like grow up. We're moving on now. The idea of the possibilities are endless now. Like, if you don't get on the wagon and get going and start building this technology for the betterment of humanity and planet Earth and all the animals, you're doing everyone here a disservice. And I'm pointing at you guys. All you academics that have been doing hot fusion for 80 years, and especially the companies that have been doing nuclear hot fusion for 22 years and still have nothing and are going public. You got to stop the nonsense. It's ridiculous. You're hurting the reputation of fusion, and you're hurting the reputation of everyone on planet Earth in a really big way. So this is why like we do these podcasts, is because we want you to stretch your mind. We want you to do gymnastics. We want you to stretch. We want you to get stronger and be more agile to what possibilities there are. Because I'm going to tell you, as we get further and further along with these academic discoveries and these exercises with you guys on the TV here, the podcasts, that it's going to get really wild. But this wildness is grounded in postulates that are true, that are real. Resonant Helmholtz, piezoelectric materials, quantum kinetic well technology, quantum tunneling, the whole radar technology, all of it. It's coming.
Wow.
In a big way. So,
well, this technology is truly next level. And I think, now with all, and without going too deep into the UFO stuff and all the things that have been released lately, I think people's acceptance of next level technology.
Yeah.
Right? Because like if you were to tell a caveman that you could pick up this thing and call his caveman girlfriend in the 20 miles over, he'd be like, no way.
Yeah.
But if now that we have cell phones, you would be like, oh, it's just a cell phone, dude. It's like, don't worship it or anything. And he would, could you imagine looking at your somebody through this thing that you're holding and you have no idea what a cell phone is? I mean, in the same way,
it's mind-blowing.
We're starting to, I think people's minds are opening up to the possibility that technologies that we thought had limits may not have the limits we thought. Cold nuclear fusion, right?
Absolutely. I mean, it's the technology. I mean, if you can make transmutation of radioactive waste go away because it's a time machine, you're literally making a artificial quantum kinetic synthetic gravity well, and the material that goes into it goes forward in time. It decays forward. Uranium takes 2 million years or whatever to decay. We make it happen in 24 hours. That's a time machine. That's crazy. I can't believe that's possible. Well, welcome to the new age. This is it.
Well, we'll revisit this again, that topic again, but I like to always ask you, are you sure it's not just shaking it apart? How do you know it's moving it? How do you know it's doing something in time? I think that's just the part where I'm like, how is that possible? How is it we can warp time?
Well, just to close up here, and thank you everyone for staying tuned, but in terms of time, when you're not close to a gravitational flux, like a planet or a sun or a moon or whatever, and you're just in the emptiness of space, the electron-positron relationship is super quick. That clock rate is quick. And that your time is going faster there. If you get pulled into a gravity well, the electron-positron's update function starts slowing down. And so you appear to be aging slower. Okay? There is a caveat to that. If you get too close to the event horizon, then time stops. And once you get past the event horizon and you fall into it, time goes really far forward.
Oh.
It zings you.
Maybe
even to the beginning.
Once you get past that threshold.
You may not ever come back, by the way.
Because I was going to ask you, when you were saying if the uranium or whatever you're trying to transmutate is going towards a gravity black hole, I would think then time's slowing down. But then once it
crosses that event horizon,
super fast forward.
Okay. And that's why you're not supposed to. If you're going, and we're going to end on this because we're way past an hour now.
Speaking of time,
if you're going to do a time travel event, you do not go to the middle. You go to the edge. It's called a time canal. You stay on the edge of it. It's kind of like a fold. It's like a Fibonacci fold.
Okay.
That stability of time. So you're locked into this time mode. But that's all I'm going to say about that.
Okay, well, we can dive more into that.
We can dive more into that as we go further, with this kind of stuff. We'll talk more about this because the government is coming out with more and more disclosure, and I think a lot of it might be disinformation to some degree.
Huh.
So we have to be very cautious of what we get from the government.
And just to put it literally, you feel that the work that you've done with quantum kinetics, the quantum kinetic well, transmutation, has given you insights to these dynamics about potentially the way that time works and potentially the way UFO flight could happen because you're seeing some of these same things happen in the research.
So when a UFO goes by a field and there's dogs in it, you know what the dogs do? They start barking like crazy. Why?
Because they hear the sounds?
20 kilohertz dog whistle.
Oh,
the UFO is resonating at 20 kilohertz. And so it makes the dogs go crazy and they start barking.
But we can't hear it.
But
right?
we don't hear it.
Yeah. Wow.
There you go.
Okay, well that's one for next time.
Yeah,
right?
We'll jump more into that next time. But thank you so much for coming on the show and talking about Mother Nature's secrets.
Yep.
And all her amazing evolutionary states and how that knowledge base can be used potentially to engineer solid state nuclear reactors for planet Earth.
Very cool.
Yeah, that was a really fun podcast, Jason. Thank you so much. That was really great.
Yeah, you bet. I'm glad we did all the research, and I think it really paid off. It's an amazing premise, and it really ties together all these different technologies and all these different materials in a way that makes sense.
It might even tie into this too. Maybe. So, okay. Well, thanks for tuning in to Quantum Connect Season 4, Episode 3. It's been really fun, Jason. Thank you so very much for coming on.
Absolutely. My
All
pleasure.
right. We'll see you guys on the next one. Take care.
Bye.